this video, what I'm going to be talking about is the periodic table. And just as a quick introduction, if you see for each box that each element exists in, there are three different important pieces of information that you will find. You will find the atomic number, you'll find the atomic symbol, and you'll find the atomic weight. Remember, the atomic number is the number of protons, the symbol is simply the symbol, and then the atomic weight is the weighted average of the atomic masses. So here's your periodic table right here, and just as a quick review, remember that the periods represent the horizontal rows, while the groups represent the vertical columns. The next piece of information that you need to know is that there are three different types of atoms that you can have. The first are metals, and so if you look, all of the elements that are in brown, those are your metals. Now, there are a couple of important pieces of information about metals that you need to know. Metallic elements, they are lustrous. They have luster, meaning they're shiny. They're good conductors of electricity and heat, and they're also solids at room temperature. So notice most elements on the periodic table are actually metals. So what I would do if I were you, the periodic table that I gave you is actually the periodic table you'll have on the AP. So I would color in addition to the charges that you just wrote, I would also color in the metals. Then the metalloids, those 6 elements, those share both metallic and also non-metallic characteristics, so that's why they're in between the metals and the non-metals. Now, the green elements, those are your non-metals. Notice all of them except for hydrogen are to the right of that ladder, to the right of the metalloids, and they are either gases, solids, or liquids at room temperature, and all of their other characteristics are opposite of that of metals. So for example, they are not lustrous, they are not good conductors of electricity. And then you have your metalloids. The next thing that we're going to be talking about is molecular compounds. Now, molecular compounds are created by having 2 nonmetals bind together. Now, the way that they're bound together is through a covalent bond, and a covalent bond results from the sharing of electrons, which we'll look at a little bit later on. Now, there are 2 different types of formulas that you can have for molecular compounds. You can have a molecular formula, which represents the actual numbers of atoms in a molecule, versus the empirical formula, which indicates only the relative number of atoms. So it's the smallest possible whole number ratio. Well, the question is, well, why would you have an empirical formula? Why not just the molecular formula? Well, if you have something like C2H4, that is the molecular formula. Now, if I wanted to know, for example, for every 1 carbon, how many hydrogens do I have, that would be your empirical formula. So your empirical formula is the formula that has been reduced to have the smallest possible whole number ratio. And we're going to be looking at how to calculate your empirical and molecular formulas later on. So in this video, we're going to go over how to determine the empirical formula for a molecule. And so really quickly, just as a review, remember the empirical formula is the formula with the simplest whole number ratio. So once I calculate my empirical formula, I can actually calculate my molecular formula, which I'll show you how to do. But let's first look at this example. So it tells me I have a compound with carbon, hydrogen, and oxygen. I have 9.1% hydrogen. I've got 54.5% carbon, and then the rest is going to be oxygen. Well, if I assume that the total mass of my sample is 100 grams, if that were the case, then I would have 9.1 grams of hydrogen, I would have 54.5 grams of carbon, and then I would take 100 and subtract those 2 from it, and I would get 36.4 grams of oxygen. Okay? And so now what we need to do, because remember, to write the empirical formula, you need CHO, and you need subscripts here. That's what I'm trying to determine. And these represent the number of moles. So I've got to take this value and I've got to convert it into moles. So 1 mole of hydrogen, what I'm going to put on bottom is the molar mass of hydrogen, which is 1.008. I'm going to do the same thing for carbon. 1 mole of carbon, but keep in mind the molar mass of carbon is 12.01 grams of carbon. And then I'm going to do the same thing but for oxygen. So 1 mole of oxygen, and it's 16 grams of oxygen. So when I find the moles of hydrogen, I get 4.538 moles. For carbon, what I get is 9.0278 moles. And then for oxygen, I get 2.275 moles. And so what I need to do, because you can't just round these values, what I'm going to do is I'm going to divide all of these by my smallest number of moles, and hopefully that'll give me whole numbers, because you can't just round this to 5, this to 9, and this to 2. Okay? So I'm going to divide by 2.275, because that's my smallest number of moles for each of these. And then I'm going to write out my number of moles. So here this becomes 2, that becomes 4, and that becomes 1. And so this becomes C2H4O, because it's a 1. Alright? Really quickly, I'm going to skip B, I'm going to go to your tips. First of all, when you are writing out your number of moles, write out at least 4 digits, because if you overround, you won't end up getting a whole number when you divide by your smallest number of moles. The next thing, you can only round a whole number if it is within 1/10 of that number. So for example, here, let's say 4.5, I can't round that to 5 because that's not within 1 decimal place. But for example, here I got 1.99. That's within 1/10 of the number of 2, and so that works. And the example I gave you here, 1.03, that's fine to say that's 1. If that were 1.3, no, you couldn't round that to 1. Okay? And then the other thing is, well, if you're in the situation in which you're not within 1/10 of the number you need, for example, if you had 1.5, what you can do is multiply the entire thing by 2, for example, to get 3. Or if you have 1.2, for example, you can multiply all of the subscripts by 5 to make that equal to 6. Okay, so that's an option, but I didn't need that here because I ended up with a whole number. Now, here it says a compound with an empirical formula of C2H4O, which is what I got, has a molecular mass of 176 grams per mole. What is the molecular formula? So what you're going to do is you're going to take the molar mass, which is 176, and you're going to divide it by the molar mass of your empirical formula. So the molar mass of your empirical formula for C2H4O is 44.052, and that's going to give you a whole number. And in this case, I get 4. What this 4 represents, I'm going to take my empirical formula and I'm going to multiply it by 4. So instead of C2, I'm going to end up with C8H16O4, and that is my molecular formula. So you take the molecular mass, divide it by the empirical mass, get a whole number, and then multiply your empirical formula by that value to get your molecular formula. And that's it.